This presentation provides an introduction to Karnaugh Maps, specifically focusing on extended K-map methods for 5 and 6 variables. We will explore advanced techniques for handling larger variable sets in digital logic simplification. Here's an overview of 5-variable Karnaugh maps. A 5-variable K-map consists of two 4x4 maps arranged in a three-dimensional configuration. This arrangement allows us to represent and simplify Boolean functions with 5 variables. A 5-variable K-map has a total of 32 cells, since 2 to the power of 5 equals 32. This slide shows the layout of a 5-variable K-map. You can see two 4x4 K-maps. The first one represents when equals 0, and the second represents when equals 1. The cells are numbered to show the min-term representation within each map. For example, in the e=0 map, the cells are numbered 0, 1, 3, 2, 4, 5, 7, 6, 12, 13, 15, 14, 8, 9, 11, and 10. Similarly, the =1 map contains the min-terms 16 through 31. The grouping rules for a 5-variable K-map. Within the same map, standard adjacency rules apply. This means groups can be formed with 1, 2, 4, 8, or 16 cells. Also, wraparound is allowed within each individual map. Between the maps, corresponding cells are considered adjacent. Groups can span across both maps, which illustrates the concept of three-dimensional adjacency. In essence, you are looking for identical groupings in both the e=0 and =1 maps to simplify the expression further. Consider a 5-variable function f of a, b, c, d, and that is equal to the sum of min-terms 0, 1, 4, 5, 16, 17, 20, and 21. Looking at the min-terms in both maps. When e=0, we have min-terms 0, 1, 4, and 5. When e=1, we have min-terms 16, 17, 20, and 21. We can form two groups. Group 1 consists of 0, 1, 16, and 17, which simplifies to be prime c prime d prime. Group 2 consists of 4, 5, 20, and 21, which simplifies to be prime c d prime. Let's explore 6-variable K-maps. A 6-variable K-map is structured with 4 4x4 maps arranged in a matrix form. A 6-variable K-map has a total of 64 cells, since 2 to the power of 6 equals 64. This slide shows the layout for a 6-variable K-map, designed for simplifying Boolean expressions with 6 variables, a, b, c, d, e, and f. There are 4 4x4 K-maps arranged in a grid. The maps are labeled as EF=00, EF=01, EF=11, and EF=10. Each cell within these maps is numbered to represent the min-terms from 0 to 63, facilitating the grouping and simplification of Boolean functions. When working with Karnaugh maps, it is important to consider some practical limitations. As the number of variables increases, the complexity grows exponentially, making the map more difficult to manage. Visual grouping becomes challenging, and the likelihood of errors increases when solving manually. For complex problems, consider alternatives such as the Quine-McCluskey algorithm, computer-aided tools, or standard Boolean algebra simplification methods. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.